Let A be the area under the curve f of x equal to x squared minus x plus 3 over the interval 2, 4. Compute the area as the limits using the right endpoints. We know that we won't be able to use the geometry in this case because this is the parabola. So we would need to compute this area using the limit. Using the right endpoint, the limit at the Riemann sum is the sum as I go from 1 to n of f of x sub I times delta x, where the width delta x is always b minus a over n, where b is 4, a is 2, and n is n in this case, because we would need to have n to take the limits at n go to infinity. So we can't use any number for n, not yet. 4 minus 2 over n is 2 over n. Then we still need to have xi so that we can write f of xi. Using the right endpoint, xi is always a plus I times delta x. A in this case is 2 plus I. Delta x is 2 over n. So this simplifies to 2 plus 2i over n. And this will give us xi. If we want to simplify this further, then this is 2n plus 2i over n, or 2 times n plus I over n. But this is only delta x. We are interested in f of xi, where f of xi will give us the height of the rectangle, and the delta x give us the width of each of the rectangle. F of x sub I is f of 2 times n plus I over n. And so we plug this expression into the function f of x, which is given. It is 2 times xi squared, but xi is 2 times n plus I over n, and we will square this quantity, minus xi, but xi is again 2 times n plus I over n, the last term plus 3. But this is again only f of xi. To evaluate the limit, it is always a good idea to simplify this. So this f of xi is now simplified as 2 times 4 times n plus I squared over n squared, minus 2 times n plus I over n plus 3. This is 8 over n squared times, we distribute n plus I squared to have n squared plus 2ni plus I squared, minus 2n plus 2I over n plus 3. And this is 8 over n squared times n squared plus 2ni plus I squared, minus, we still need to simplify this. 2n over n is 2, plus 2I over n plus 3. Simplifying this further, this is 8n squared over n squared plus 16ni over n squared plus 8i squared over n squared minus 2 minus 2I over n plus 3. We then combine like terms. But first, 8n squared over n squared is 8. 16ni over n squared is 16I over n, plus 8I squared over n, minus 2I over n plus 3. The like terms, the constant terms are 8, negative 2, and 3. 8 minus 2 plus 3 is 11 minus 2, or 9. 16I over n minus 2I over n is 14I over n. and we bring down 8i squared over n squared. And this is the height of the rectangle. It is only the height, not the area, not yet. And so the right sum R sub n is the sum I go from 1 to n of f of xi, which is the height, 9 plus 14i over n plus 8i squared over n squared, times delta x. But we found that delta x is 2 over n earlier. We then distribute 2 over n to get the sum as I go from 1 to n of 18 over n plus 2 times 14 is 28, 28i over n squared plus 16i squared over n cubed. To evaluate this sum, we would need to split this into 3 sums. The first sum is I go from 1 to n of 18 over n. The second sum is I go from 1 to n of 28i over n squared. And the third sum is the sum as I go from 1 to n of 16i squared over n cubed. And we will evaluate each of these sums individually so that we can simplify the process. First, the sum as I go from 1 to n of 18 over n is 18 over n, the sum as I go from 1 to n of 1, because 18 over n doesn't depend on I. But the sum of 1 n times is n times 1, so this sum is simply 18. Next, the sum as I go from 1 to n of 28i over n squared. We factor out 28 over n squared and bring it to the front of the sum because, again, this factor doesn't depend on I. Inside the sum, we have I. So this is 28 over n squared. The sum of I as I go from 1 to n is the sum of the first n integers, and this is n times n plus 1 over 2. So we have 28 over 2, which is 14, times n plus 1, and we cancel out one factor in the denominator to get n. For the last sum, we have the sum as I go from 1 to n of 16i squared over n cubed. And similarly, we will factor out 16 over n cubed because 16 over n cubed does not depend on I. This is now the sum of I squared. So this is 16 over n cubed, and the sum of n squared is n times n plus 1 times 2n plus 1 over 6. We then simplify this. 16 over 6 divided by 2, we get 8 over 3. N over n cubed, we have n squared in the denominator, and in the numerator, we still have n plus 1 times 2n plus 1. We then simplify this further. 8 over 3n squared. We then distribute n plus 1 times 2n plus 1 is 2n squared plus n plus 2n plus 1. This is 8 over 3n squared times 2n squared plus 3n plus 1. Distribute 8 over 3n squared. We have 16n squared over 3n squared plus 24n over 3n squared plus 8 over 3n squared. And this can be simplified further. 16 over 3 plus 24 over 3 is 8, and then n over n squared is 1 over n, plus 8 over 3n squared. And so, putting all of these together, we have the right sum is 18. This is the first sum, plus the second sum is 14n over n plus 14 over n. And the last sum is 16 over 3 plus 8 over n plus 8 over 3n squared. 14n over n is simply 14. We then combine like terms. There are three constant terms, 18, 14, and 16 over 3. 18 plus 14 plus 16 over 3 is 112 over 3. And so R sub n is 112 over 3 plus 14 over n plus 8 over n is 22 over n plus 8 over 3n squared. We're taking the limits at n go to infinity of R sub n, which is the limits at n go to infinity of 112 over 3 plus 22 over n plus 8 over 3n squared. And as n go to infinity, the last term go to 0, the next to last go to 0, and so we end up with 112 over 3. This is the exact answer for the area under the curve.